Good morning, class, and welcome to Unit 4, Lesson 1. Today we're going to go ahead and look at exponential functions. If you don't have your graphing calculator handy, you might want to go ahead and grab it. You're going to want that today because we are going to be graphing exponential functions. The first thing we're going to do is we're going to actually go ahead and look at some functions we've graphed in the past. The first one is linear. The reason I know it is a linear function is because it has x to the first degree. Okay, anything that has an x to the first degree as its highest exponent, then we know it's linear. So we could fill out a table for this one, but we know this has a y-intercept of 0, and then the slope is up 2 over 1. Or we could go to the left 2, down 2 to the left 1. And then we could graph our line. Going through there. Okay, so that's an example of a linear equation. The next one is an x squared. We should all start thinking what that one would look like. That is going to look like a parabola, a U shape. Okay, anything that has the x squared, it's either going to be a U-shaped up or U-shaped down. This one's going to go up because it's positive, and I could plug in numbers again to figure this out. So if I plug in -1, -1 squared is +1. Plug in 0, I get 0. If I plug in 1, I get 1. So I'll have 0, 0. 1, 1, -1, 1. If you also plug in 2, 2 squared is 4. So, whoops, I did not get that on 2. There it should be. -2, 4 as well, because -2 squared would be +4. Ooh, my parabola is not looking very good there. Make sure it doesn't look like a line. That's kind of how mine looks. So, there we go. So there is our quadratic function. Now we're going to move into exponential functions. The biggest thing is people get stuck on exponentials is they try and graph it like a line or they try and graph it like a parabola. You need to recognize an exponential function is when the variable x is in the exponent, okay? It is an exponential function when x is in the exponent spot. So if we go back, notice that this is x to a number. These are now going to be numbers to an x. So there's two types of exponential functions when we graph them, just like you could say there's two types of lines. You could go up as you go from left to right, so positive slope, or down as you go from left to right. The other thing is parabolas, right? If it's positive, it goes up. If it's a negative, it goes downward. So exponentials, if this number is 3 is bigger than 1, okay? So whatever this number is, usually refer to it as A. Sometimes it'll be B, but if the number being taken to the power of x is greater than 1, it is going to actually be a growth function. So as you look at it from left to right, it should go up. If this number here is in between 0 and 1, it's actually going to be a decay function. And the way we're going to figure this out is by graphing them. You have your calculators. My calculator does not work when I'm not at school, so I'm going to plug them in. But you could go ahead and put this into your y equals, right? Type it into y equals, and then go to your table and plug in these values. I'm just going to plug them in by thinking about it. So if I have 3 to the -1, it's really 1/3. Or 0.3 repeating. If I plug in 0, 3 to the 0 is 1. And if I plug in 1, 3 to the first is 3. So exponential, I will have -1, 1/3. Kind of hard to plot on this tiny graph, but there it is. And 1, 3, 1. And all exponentials make this shape. They get, ooh, it's kind of hard to draw in here. It's very, very, very close to the x-axis, but never actually touches the x-axis. Okay. So if you look at this one as you go from left to right, you should see that it's going up, and that is an indicator that it is growth. Okay, let's graph this one. If I plug in -1, I actually, for x, I'd have 1/3 to the -1, gives me out 3. If I plug in 0, I still get 1. Anything, the 0 power is 1. And then if I plug in 1, I get 1/3. So kind of the reverse here. So I have -1, 3, 0, 1, and then 1, 1/3. And if I graph this, it's basically the same shape except for it's reflected across the y-axis. And as you look at it, it should, from left to right, go down. So this is an example of decay. So that is growth and decay. So just kind of recapping on some of the things I talked about. This is your formula for exponential. You have some number to an x. If a is greater than 1, it's growth. If it's in between 0 and 1, it's decay. So here's some examples of growth. This 2 tells me that I'm bigger than 1, I'm going to grow. 5 over 2, so don't just because it's a fraction assume that it won't, but that would be 2.5. That's a growth function. Same thing here. This is 0.5 and 0.75, which is in between 0 and 1. So those are exponential decay. Transformations. How do these graphs compare to f of x? Okay, how do these changes? So what you could do is you could graph these on your calculator. We have been looking a little bit at transformations, so you might already be able to take a guess, but let's go ahead. I have Desmos. You can graph these on your calculator, but what you do is you'd graph your original function. So I would have 2 to the x, oops, that's not what I wanted, 2 to the x power. Okay, there's my exponential. That's the original. Then the first problem we want to go ahead and look at is 1 plus 2 to the x. 1 plus 2 to the x. What does it look like happen to that graph? If I zoom out, you might be able to see. My red function is my original, and the blue is the other one. So what happened there? We went ahead and moved. We're careful. Looking at them. We went up 1. So in this case, we went up 1. That's how it compares. Let's go ahead and move to B. I'm not going to graph it, but this was a positive 1 and this is a negative 1. So the guess would be that we are going to go down 1. Once again, you could graph it and have support for it. Let me see if I can grab mine. I can change this real easily. Just make this negative. Correct. It went down 1. The next one we're going to go ahead and look at is negative 2x. What happened to that one? We went from the red function to the blue function, so we were flipped. But remember, in math, we're getting older. We're not going to try and use the word flipped anymore. We're going to use reflection. And which axis did we go across? The x-axis. So if you have a negative in the front, okay, it's a reflection over the x-axis. And the way I always like to think about it is if it's in front or not on the inside, these are things that are considered on the inside. Okay, if they're by the x, they're inside pieces. If they're on the outside, like +1, -1, they're changing all your y values. This negative is taking all my y values and making them negative. So for instance, if I had the point 1, 2, if I made my y a negative, I'd be 1, -2. And then you'll see that you go across the x-axis. Let's just say I added part f. What if we had g of x equals 2 to the negative x? Which values am I changing now? Here I was changing my y's. Now I'm making all my x's negative. So if I have x's that are negative, let's say I had, once again, 1, 2. If I make my x value negative, I'm now at -1, 2. So which axis did I go across in this case? I would have went across the y-axis. So this one is a reflection over my y-axis. And then the last two I kind of alluded to, but, oh my gosh, I want to erase that. There we go. Okay, so we're going to graph them. These ones are in the exponent, and when they're in the exponent, they pertain to x's. So if I go ahead and look at this one, I'm going to delete this. And part D is x plus 1. It will not let me, it looks like, type up there. 1, there we go. Just wrote in the reverse order. There we go. So this one, we did x plus 1. So the red function was my original. So if you go ahead and look here, and then what happened to it? We went to the left. Think about with our circles, when we had the equation, the inside was always the opposite of what it looked like. Okay, so it looked like +1, which you might think to the right one, but really since it's on the inside, it's always the opposite. So in this case, it's +1, so we're really going to go to the left 1 unit. How about here? This one looks like we're going left 1 unit, so guess what? We go right 1 unit. And we can back that up by graphing it, and you guys will always have your calculators handy. So if I just make it negative, you should see the red's the original, and I went to the right one. So there we go. That is our transformations. The next thing that we have to talk about is the natural exponential functions. We have e to the x. E is a number like pi, okay? It is not a variable, so you have to be very, very careful. Some people start thinking it's like a variable. It's not a variable, so it's like pi. It's a numeric number, so like pi. When we get into word problems, whenever you hear that things are compounded continuously, you are going to use e. And e can be found on your calculator on the left-hand side above, I'm just going to grab mine really quick, ln for sure. Okay, yes, if you look above ln, you'd have to do second alpha to get to it. Also, e would be above your division sign. That's e to the first power. So if you actually click second division sign, you'll get just e. And if you hit enter, you should be able to get that number up top. 2.71828 on your calculator. That's why it's like pi. Pi is 3.14. E is 2.718. Just not as well known as pi. Okay. So, speaking of continuously, let's go ahead and move on to what kind of problems we're going to use this for. Interest, compounded interest. You will be given these problems, you'll be given these formulas on your test and quiz for this unit, so if you need them. But here's how they work. If you are compounded interest, if you hear that you're compounded quarterly or weekly or monthly, you're going to use this equation on the left-hand side. If you hear compounded continuously, you're going to use PERT. Okay? So what does all of this mean? So A of t is the amount in the account after t years. So it's like what you get out. You plug in all this information and what do you get out? What is your current balance of your account? P is the amount invested, or your principal. I always like to say your starting amount. How much money did you start with? Starting. R is the interest rate, and it always must be written as a decimal. And then N is the number of times compounded per year. So if you hear daily, that's 365 days a year. Weekly, there's 52 weeks in a year. Monthly, 12 weeks in a year. So there's all of those. So that's what N is. And then T is the number of years it's been invested. Okay, so we have those equations. So example 1. A sum of $1,000 is invested at an interest rate of 2% per year. Find the amount in the account after 3 years if it is compounded monthly. Okay, so since it's compounded monthly, we will be using A. I usually just write A, but you can write A of t is P. Then we have 1 plus R over N to the NT. Okay, so let's figure out what all of this information is. So we have $1,000. That is going to be our P because that's how much we started with. Okay, so plugging that into here. Our rate is 2%. So make sure you put it as a decimal, move it over twice. So 0.02. That is your interest rate for R. So that's what your R value is. It says find the amount in the account after 3 years. Well, 3 years is time, so that means T is equal to 3. And then the last thing, if we're compounded monthly, how many months are in a year? There are 12 months, so that means N is 12. So we're going to plug all of this in. So A of T, technically we're plugging in T. A of T is 3. So A of 3 equals our 1,000, 1 plus 0.02 divided by 12, all to the N, 12 times our T, which is 3. And then you can actually just go onto your calculator and type in everything on the right-hand side. Make sure you use parentheses when you type it in. So I would type it in, and you should get the following answer. And make sure, since we're talking about money, whenever we talk about money, we want to run to 2 decimal places. So you should get $1,061.78. So after 3 years, this account has gained $61.78. That's just by typing that all into your calculator. So make sure you take the time, type it in, make sure you can get that answer. Okay. Part B says a sum of $1,000 is invested, compounded continuously at 2%. So this is different because now it's continuously, so this is where you use PERT. Every time that you hear continuously, you're going to use PERT. So A of t for this case is P e to the RT. So same information, except for now we don't need n in order to solve this because it's always being compounded. So when I plug it in, we will have A of t equals our principal, 1,000, e to our rate, 0.02t. So this time I didn't plug in 3 right away. I just want to point out, if they ask you to write the equation to represent this situation, this would be it, right? You input t and you get out your amount. So this would work for any time. Now I'm going to find A of 3, so I'd plug in 3. So if they just ask you for the equation, it would want this. And then if they say solve it, then you'd plug in 3. So we'd have 1,000 e to the 0.02 times 3. Then you take the whole right-hand side and type it in. So remember, e is above ln. And if you type it in, you get $1,061.84. So which one's a little bit better investment? Continuously. So if it's your money that's earning interest, you prefer continuously. If it's a loan that you borrowed from the bank and the interest accumulating for you is compounded, you probably want it to be monthly. So just something to think about. Most banks compound things continuously, so it means it's always accumulating interest. But there's that. Okay. All right. The next one. Evaluate the function round to 3 decimal places. So your calculator will be helpful. In this case, you could also go ahead and put this into your calculator, into your y equals, and then go to your table and just type in these numbers because it says to round to 3 decimal places. Okay. I'm going to walk through them without a calculator since we don't have one. So I'm plugging in -2. So it's really 4 to the -2 plus 1. -2 plus 1's -1. And I would think about this as 1 over 4 to the positive first, right? If I bring negative exponents to the denominator, which is just 1/4. And if it wants decimals, I'd write it as 0.25. Good. The next one, plugging in the square root of 5. It's 4 to the square root of 5 plus 1. I wonder if I can do this on Desmos. You guys all have your calculators handy though. No, I don't think I can. It'll just give me a line graph. So if I type it in, here's what you should get. Rounding it to 3 decimal places, you would get 88.778 if you round appropriately. The next one is that you're going to plug in e. So you have 4 to the e plus 1. And when you type that in and round to 3 decimals, you should have 173.232. So I really, really hope you all are right now taking the time to type these in because you're going to have to do this stuff on your test, on your quiz. And if you don't practice it now, there's no way to be certain you're typing it in right. Okay. So then the last one, 4 to the -1/2 plus 1. This really gives me 4 to the 1/2. Oh, the same thing as 1/2 is a square root. So I have the square root of 4, which is 2. So type it in, make sure you can get the correct answer, okay? Then we're gonna go ahead and graph. Same thing, go to your y equals, type in 4 to the x, and then go to your table and type in -1, 0, 1. Notice all of these for exponentials, you can do -1, 0, and 1, okay? So kind of that's what your table setup would be for exponential functions. I'm gonna do it once again without, but you guys can use your calculator because it's handy there. So we have 4 to the -1, which is really, we just did that one, 0.25 on the last slide. Anything to the 0 power is 1, and 4 to the first power is 4. So I haven't graphed this yet, but let's think about it. Should this be an exponential growth or exponential decay? 4 is my a value. It's greater than 1, so we should be going up. So hopefully that's the case. It should be exponential growth. So I have -1.25, then I have 0, 1, then I have 1, 4. And we know what the shape is. And you could also go ahead and hit graph on your calculator to see if it looks like this. It will not cross your x-axis, but there's your exponential. Okay. And this is a growth function. Okay. Next one, you could once again go to your y equals, do it that way. Otherwise, you have 2 to the negative 1, which is 1 over 2, so 0.5. 2 to the 0 is 1, and then 2 to the first is 2. So I have negative 1, then I have 0, 1, then I have 1, 2. And 2 is bigger than 1, so once again, it should be a growth function. The next type of problem we have is that you are given a graph. And it says, find the exponential equation whose graph is shown. So what we need to do is figure out what is my a value. So the way we handle this is we're going to grab off a point on here. Okay, so we grab off this point. I'm going to grab this one. What is this point? 2, 9. Ordered pairs are always x and y. Okay, and I could really think about this as y equals a to the x. And what I need to do is figure out what a is. I know a is going to be a number that's bigger than 1, because as I read from left to right, it is a growth function. But I don't know specifically what number it is. So I go ahead, I'm going to plug in what my y is, 9, a to the second. And then I would just solve for a. The way I get a by itself, take the square root. So positive or negative 3 is equal to a. And since it's growth, I know that it's a is equal to positive 3, because it has to be bigger than 1. So then to write the equation, it'd be f of x equals 3 to the x. There it is. Could I have used another point? Yes, I could have used 1, 3. Probably would have been a lot easier to use 1, 3. But y would be 3. Sorry about that. Okay, y would be 3a to the first power, so a is equal to 3, and I would get the same answer. Okay. The next one, not looking as nice, maybe. I don't know. Let's grab a point, though. I would have, I'm going to use this one. Because sometimes you're going to only be given harder information. Let's use this one. We got negative 1, 1/2. Okay. So what I'm going to do is plug in the information I know. This is really y equals a to the x. I know my x is negative 1. And my y is 1/2. Okay. There are easier points you guys could use, but I just want to, when you take your test, I might remove all the grid and just say, hey, here's one of your points, and this is what you're going to have to do. So it might be a harder or more difficult problem. So I'm going to go ahead and rewrite this. The left-hand side is 1/2. Now I have a to the negative 1. We have talked about negative exponents. What you can do is go ahead and take them, move them to the denominator. So I have 1 over a. And now I'm trying to solve for a, so I can cross multiply. So I would have a times 1 equals 2 times 1. So a is equal to 2. So that would give me my answer. Y is equal to 2 to the x. Or f of x equals 2 to the x. If I was given an easier point, let's see what I got here. I got 1, 2. That'd probably be the easiest point to use. Y would be 2. X would be 1. So I would get the same answer. Okay, so there's example 4. We have some your turn problems. I would recommend you pause it and then go ahead and do it. But I'm going to write out the answers for you. So, but pause it and try them on your own first, please. A sum of $10,000 is invested at an interest rate of 2.5% per year. Find the amount in the account after 8 years if the interest is accumulated continuously. So as soon as I hear continuously, I know I am using PERT, P-E to the RT. Okay. So my principal is how much money I started with, $10,000. E is it's not a variable, it is a number, so I can just write it out. R is my rate as a decimal. A lot of people say this is 0.25. No, that's 25%. This is 0.025. Okay, so 0.025t. So this would be my equation. Okay, but they're not asking me just to write the equation. They say after 8 years, so I'm going to plug in 8 for t. So I have 10,000 e to the 0.025 times 8. You should type it in. You should round to 2 decimals, and you will get $12,214.03. That is the example 1, your turn. Example 2. The sum of $3,500 is invested at an interest rate of 1.5% per year. Find the amount in the account after 15 years if the interest is compounded quarterly. So it tells me I'm going to use my compounding equation, which is P, parentheses, 1 plus R over N to the NT. So let's fill it in. So we have A of T equals our principal, how much money we put in, which is $3,500. Then we have 1 plus our rate. Move it over 2, so 0.015. Divided by n. N is the number of times, quarterly. So n is 4. To the 4t. And we are specifically finding it after 15 years, so now we're going to plug in 15. So A of 15. So this is a lot of just now typing it into your calculator. So 4 times 15. People will get these wrong if they don't take their time now to try and type it into your calculator. So make sure you do that. Okay. So when you do this, you will get $4,381.29. Good. And the last, your turn. Find the exponential equation for the graph who is given. One thing to take note of on this one is we're going down. So what should my A value be? Should be less than 1. Okay. So I'm going to pick a point. I'm going to do -2,4. And so really it's y equals a to the x. I am going to plug in my x value and my y value. So 4 equals a to the -2nd. Whenever we have negative exponents, we rewrite. Okay. So I'm going to rewrite this one. I have 4 equals a to the -2nd. I'm going to rewrite as a squared. Now, what we could do is times both sides by a squared. So I have 4a squared equals 1. What I did was times by a squared. These cancel. And I'm trying to get a by itself, so I would divide by 4. So a squared is equal to 1 over 4. And then to get a by itself, square root. So a is equal to plus or minus the square root of 1 over 4. Well, the square root of 1 is 1, and the square root of 4 is 2. And now a has to just be in between 0 and 1, so we're using the positive number. So our equation is f of x equals 1/2 to the x, which makes sense because we are going down from left to right. Okay, so it should be less than 1 but greater than 0. So that is it for our notes today. Here's our check of all the things we've done. And here is your homework. Make sure you complete evens for all of it. Okay, it's all evens for the entire 2 through 24, 76, and 80. If you have questions, feel free to message me on Schoology, or I'll go ahead and see you at class next. Take care.